All right. So we've got some goals tonight, right, Craig?
Yes, indeed. All right. So we took a look last time about how we're going to move our mainnet application. It is an NFT platform over from mainnet over to Polygon. So a couple of the requirements we were looking at last time was the payable function. We need to make sure that we are paying in wrapped ETH.
Hmm.
Um, so I think that's where we left off, and let's take a look at some of our code, see what we can do. We're going to be deploying on the Mumbai Polygon testnet, and we'll see how far we can get.
Yeah, excellent, cool. So that was kind of an interesting discovery on our last call, which was we were thinking that we could just deploy this contract that we have currently on mainnet over to Polygon, but ETH is not the native token in Polygon, so we can't just have a payable function that takes ETH. It could take Matic, but it's not going to take ETH.
But charging 0.15 Matic wasn't really
Yeah, no, that's not a completely different pricing model there. So I'm going to go ahead and share my screen here, and I have our Asana up, which we have kind of some tasks in there just to kind of give you an overview of what we're trying to achieve, and then we're going to dive right into the code and show you where we're at and see how far we can get with this. All right, so this is kind of our roadmap right now. Right now, we're kind of focused on setting up, deploying a contract to Polygon, and connecting the front end to the Polygon contract. So last call, we did record it, but it kind of went a little haywire. We did deploy something to Polygon. That's kind of where we discovered the whole wrapped ETH scenario. We needed to support that. One problem, if anybody watches this, that we noticed was we needed to call into an ERC20 contract, and the question that we were having is how do we actually test this, right? We know the wrapped ETH ERC20 address, we can get that, but we're not going to test with test wrap ether. I guess we could, but
I think the critical item was you said it tests locally. So the local node doesn't actually know that the wrapped ether contract exists. So it can never actually call into it.
yeah, exactly. So if we're running this locally, where we are using Hard Hat spins up kind of a local test blockchain that we can then test to. How do we test that? So I think conceptually we figured that out. There's probably some effort there to create a test ERC20 token, deploy it to the test net, then call the approve function, and do all that type of stuff. But instead of doing that, what we're going to do tonight is we're going to kind of shortcut it a little bit. We're going to go right to the test net. We're going to deploy to Mumbai an ERC20 token. And then we're going to go right to our front end and say, hey, make a call to approve that token for transfer. And then once we do that, we kind of already have our contract modified to take a token in as payment, as opposed to taking the native token in. So then once we have that, we're kind of almost killing two birds with one stone, because we're going to test the transfer of this test token, and then at the same time kind of develop our front end for this slightly different type of workflow that users are going to have to experience when they're on a layer two like Polygon.
Yeah.
That makes sense?
I mean, it's not slightly. I think we're gonna have a lot that we're gonna have to do,
Yeah, yeah.
but that makes it fun.
Yeah, so let's see where we're at. So, whoop, that's our Slack. Let's go ahead and make sure that I'm not blasting private keys again. But we aren't live now, so we can always go back and edit.
Yeah, that means we have to go back and edit.
Yeah, exactly. All right, so here's our code base right now. I've got a bunch of scripts that we're using to interact with some of the contracts. I just a couple minutes ago just developed this super simple test token that is going to enable us to just deploy a test token to a test net. And I have a script here that's basically just going to go ahead and deploy that token. So I'm going to run this, and this is going to deploy a test token to Mumbai. So we already have Mumbai configured in Hardhat, and Craig, cut me off at any time because I'm kind of just going to keep talking through this because we're recording. So
let's just run it.
Cool. And I'm caffeinating with Dr. Pepper at 10 o'clock at night, so I'm probably going to start talking really fast.
All right, I already had my coffee.
So this script is going to go ahead and deploy the test ERC20 token. And this should just return an address. And that address is going to be our token. We're going to use that address to integrate with our front end. So boom, that worked. We have a token. Now if we go to, this is actually the second one I deployed. If we go to that address.
Just I'll let you finish, but just a suggestion, when we get rocking and rolling, really, don't feel the need to fill that dead space and give us that time to actually edit it out and go to the, like we've had calls when we're saying like, hey, that like last 8 minutes that we talked about, that was really good content. Let's look for those rather than like
fill everything. Yeah. Okay, cool. All right, so we have a test token, right? So now here's our test token. I've been trying to get the verify feature on Polyscan on Mumbai working, but the plugin I have just isn't working for some reason. It'd be much easier.
Did you get the API key?
Yeah, we have the API key. It's not working, but we're gonna try to kill two birds with one stone. We're just gonna build it in the front end. So let's go to the front end.
Well, project. And also wasn't it because we were deploying it as a factory? So if you just created it as a token without a factory and you still can't
still can't do it. I just tried it a couple minutes ago and it wasn't. So this is the Nifty Underground project, and if I just let's go ahead and open the code base, and then we'll run the development server. So this is Nifty Underground. This is currently what we have live, and we're going to change this around a bit because we're going to layer 2. So this is a Next.js app for anybody that's interested in that. So it's a Next.js app that has a couple of components that goes out and integrates with Web3. So let's go into our code and now we have Connect working. We do need to develop a button that'll actually add Matic Polygon to that. We're not going to be concerned with that right now. We just really want to call into this token so that we can approve it, and then we can call into the actual test contract to try to mint something.
We have to change our test contract anyway to accept only that outputted token in.
Yep.
Right.
Yeah, exactly. So we can
and then.
Right. We could do that now, but let's try to just get the approve first.
Yeah.
So why don't we do this? Why don't we get crazy and we just make this look like garbage? I'm gonna create another button just for approve, just to prove that we can actually do this, and then we can fit it in all nicey nice once it's working. So we have a mint button already, and this mint button has a bunch of styling on it. I'm going to start with this code base. I'm going to copy this, and I'm going to create a new component, and we're going to call it the approve button. And we're going to slim this down a bit, but this does have this contract ABI, and we're going to need a little bit different ABI for what we're trying to do here. And if we go back to our backend, when we compile with Hardhat will keep the artifacts of the contracts right here. So this is kind of what you were just saying before, Craig. Because we used the factory earlier on, we didn't have this ABI available, but it's technically a standard ERC20 ABI. We could probably just get it on the internet. But
what does ABI stand for?
Application Binary Interface.
Got it. So it's like the compiler.
It's like the mapping of what the inputs and outputs are of a specific set of functions within a given piece of code, specifically a compiled piece of code. So like you can have like a blob of compiled binary data, and this is a string that basically says, hey, these are all the features that that big blob of binary data exposes to you and returns to you. But now we need to find the approve. So here is the approve function. Let me just make sure that name mint, name approve. So here to here is what we need. So this little blob here that I just copied, this segment of, this is like JSON format. This describes the approve function, and it describes it in two ways. Well, really, I guess three: the name, the inputs, and the output. So if we go now, we can use this and replace this, which is describing the mint function.
Got it.
And now we have the contract API that we need for approving this token. And we're not going to change the style, but we'll call this approve. And we don't need a quantity. We don't really need to do any of this. We're checking to see if we're connected. So this already has some of the logic in there for checking to see if our wallet's connected, which is good. We're going to need that. And the contract address. Where do we get the contract? Ah, here we go. So we need, I'm going to comment this out. And
we need a Mumbai.
Yeah, we're going to, oops. We're going to grab the Mumbai. So we'll just say contract. I'll say test token address. Ooh, and I'm using GitHub's Copilot. If that's the, oh no, that's not the, that's this one.
That's the main net.
Yeah, I'm gonna say if they got that right, that's like freaky, man. That's like
we did this once already.
Yeah. All right, so that's the address.
Contract. What am I looking for?
Well, I got it already. It's in there.
Oh, okay.
It's in there, yeah. So this is the ERC20 that we just deployed.
Oh, yeah. Okay, got it.
So now we.
You were thinking it may have picked up that you were trying to get the kind of.
Yeah. That's just weird. Are you just?
So this is listed. Oh, as mint button. Okay, got it.
So let's say approving, and then here. We're going to use the token address, contract API, set loading to true. We don't need a price.
Oh, you defined it up there. Now you can call it there. Got it.
Yeah. So now here, we're not calling mint. We're calling approve. We're going to use the account, the first account. We don't need any quantity. And we're not giving it any value. So we actually don't need any of this. And we'll catch any errors. We're not really doing anything with errors right now, but it's okay. And we're not going to go to the gallery. And okay, cool. So what is this? I may have spelled something wrong here. What is it? The hell do I use this props for? All right, well, we'll keep that in there. We don't need the quantity. We'll say if it's loading or approving. And then.
How did it define loading?
So that's a state that we set in this React component right here. this is using, so this is a React thing. This is using the use state hook,
Okay.
which that's kind of like what React is. Like React.js is basically like a state management system in some respects.
I got you.
It kind of, but all right.
But that's not a Web3 call. That's just the React call of
Yeah.
I've clicked something, I'm expecting something.
Yeah, I click something. I'm going to say, oh, we're loading. We're waiting for something. We're waiting for something. Oh, we got something. I'm going to set loading to false. That's how you can do like nice spinners and all that type of shit.
Yep. And hence React.
Yeah, you can react to the state. We don't need the drop down on this. And now when we click this, we want to call mint, and I think we change that up here to approve. So that's going to be approve, and we'll call this approve. I'll call it wrapped ETH. It's not actually wrapped ETH, but whatever. We don't need any price in here because that doesn't make any sense. Take that out.
I mean, there's another reason I'd be a terrible coder. I'd be way too sarcastic with my code. All the time. Anytime I could be.
I'd be real surprised if this is going to work off the bat. Let's see how this fails, because it probably will.
Yeah.
But let's see. So we're going to return mint button. We're not calling this mint button. We're calling this approve button. I think that might be enough for us to actually. We're not really doing anything once we get the transaction, but we are console logging the receipt, so we'll be able to see what's going on here.
How come we've never had to do this before?
What do you mean?
To create to do an approval functionality.
Because we were taking the native token of the chain.
Got it.
Yeah. Now we're not. Now we're taking an ERC20, which ERC20 is by default. You need to have an approval, and then you
got an NFT. If we tried to do anything with the NFT, do you need to know because they were calling the contract, paying in the native token, and then they're the owners and can do whatever the hell they want.
The second they want to use that NFT on another site that does something with that NFT, there is an approve that you need to call.
But we've never had to do that because we're not doing anything with it yet.
Exactly. Yeah. And that like with an NFT, it's not because like you can verify ownership with an NFT without actually doing anything with the NFT. So you don't need to.
You can't level it up or something like that.
Yeah, you can't, or transfer it or whatever, do something. We're changing something about it. All right, cool. So let's go ahead and try to now put this in the front end. So this is just the component. Now we need to actually put it on the page. So let's go to our, let's go to our pages, and let's just go to our index page, and actually mint convergence. So we have this actually in a mint convergence here. So this is where the meat of our stuff is. So we're going to go ahead and
that mint button.
We're going to import. Now, there we go. Import the approve button, and let's just throw this on the page someplace. There's a lot of styled component stuff that's duplicated all over the place, and that's probably if we get the opportunity to clean up the platform a bit, that would be a good kind of cleanup task. Is refactor a lot of the styling.
That sounds like an opportunity to be outsourced.
yeah, or somebody that wants to contribute and get involved with it for sure. So we could just put the approve button on here, and I'm going to pass in the same styling props here so that we do allow some props to come in here. So let's see, now there should be an error. Approved button is not defined.
Yeah, didn't you call it like test approved button?
So what did I do wrong? Yeah, did I call it something different?
Yeah, I think you called it.
Yeah, I didn't actually name it here, so I got to call it approve button.
There you go. I was wondering why I kept calling it. Yeah. Did it work? Get the fuck out of here.
Well, it rendered. It didn't. We don't know if it
Okay.
worked yet. So like now we need to
Yeah, bring the button that you just created into it.
exactly, yeah. So I'll use this. Well, we got to go to. But I don't have anything. I got to go into a browser that has that other wallet because there's no. So I was minting with the our deployer wallet for Nifty Underground, which is on this other computer, not this computer. So let's see what happens. This is gonna fail because this is using a wallet that doesn't have any.
Can't you just pull the seed phrase over? Or you have to. So is there anything else on this MetaMask, or that's just the defunct wallet?
This is the defunct one.
Okay, and you have the seed phrase or the private key securely put away somewhere.
For this one?
Yeah.
Yeah, probably got to back it up again.
Okay, never mind then.
Yeah, I'm not gonna just delete. Like, yeah. So let's just see if we go to.
You need to get better at that.
Yeah, I mean
you're ready to delete an account at any moment.
Yeah, that's this soft wall. I have it written down someplace, but this soft wall, it's just. I gotta get it off this machine. Okay, so we're on Matic. We don't have anything here. We don't have anything in this wallet, so this will fail. But we could see that it actually tries to at least call into it. So let's see. Okay, so we got the approving console.log, but we didn't actually
do anything.
Get the web recall. Well, you know what? Because no, my wallet's connected.
Well,
wallet's connected. Didn't actually get it. So we got approving. Account size. Let's see if we're getting here. Accounts detected. We're getting some type of error here.
I bet you still have it called mint and approve somewhere.
That's weird that would happen the second I put that in though. Was that just happening before we didn't see it?
It was happening before. I just didn't know if you expected it.
I'm not sure this is. Yeah, it's just complaining about a class name. I'm not, and these are all warnings, so it should be okay. But we're not getting here, so let's go ahead and console.log accounts. This must be undefined here. All right, so let me try disconnecting this. Okay, so we do have the account now. But we're not trying to make the call. So let's see, are we getting, so that means we're probably getting here. Okay. Are we getting here? We are. This should probably be in this conditional, but okay, that's okay. But now, okay, we have the contract. Test token address, contract ABI. Did we change? No, contract ABI is right. Oh, maybe we are getting an error here. We're just not logging anything. So let's see, console.log e. There we go. Error, missing argument passed. Ah, okay, good. So we got we just have to use the errors that we received back. That's important.
That's cool.
So what is the inputs to this again? We need the address. Oh, and the amount. We need to give it the amount we're approving for.
Oh, 0.15.
Yeah, and we need to do that stupid math stuff again, right?
Oh yeah, big number. Oh, we get a chance to go check out that tips and tricks I sent you.
Yeah, I think that we could actually use some of that here. I think I already did that here. Here we go. Ether, parse ether. This is the ethers library, and I think this is in that tips and tricks here. So we can call this, say, parse ether 0.05 is all we need to approve for. And this is kind of, I think this is kind of a responsible way to do it. I wonder how a lot of other folks do it. Like, do they try to approve for more than they need, right?
And what, refund it? Like, what do you mean?
No, that means that there's going to be an approval sitting out there for any amount, right? I think there's like there's probably a default value we can put.
Oh, they do a blanket approve,
mm-hmm.
Like a range. Like, does it act? You're saying it requires an approval amount. Do we actually require an approval amount?
Yeah.
So
there must be.
They must have it as like a range of some sort, or big if. Or they do it exactly how we're doing it and prove it for the specific amount.
Yeah, they might do it like this. I think this is the right way to do it, because now we're error value must be a string, which yeah, I got to get better with these. The way that you create and change. So parse ether. I'm curious, what the fuck does this return?
Your GitHub robot's ready to jump in.
Yeah. What is this complaining about now? If I just do this, that's not right, but let's see.
Invalid argument. Which one?
It's just 0.05. It's freaking not the right format. So let's go ahead and look at
0.05 instead of 0.05. Up above in the parse ether. There you go.
Oh, this? I don't think it's let's see. I didn't even log that, did it? No, let me change this. I don't want to see these warnings. Get this out of here. Oh, here we go. Where did that? Just want to see errors. I guess those are still logging as errors, though, aren't they? Yeah, they are. All right, let me get this out of here. Okay, so let's go to ethers.
What did you do it without the concern of how the calculation doesn't matter. Oh, but you already set the approval to only 0.05.
Yeah. Or maybe let's do this. ERC20
We can make it the same.
approval. JavaScript. See if there's any. Yeah, see, look at all this like
Hex numbers.
Yeah, like so they what they did here is he's got this token to approve amount Web3 dot. So he's using the Web3 library.
Well, that's what I was gonna say. Just do Web3 big number, and it doesn't, as long as they match. Call it 99 and then let's just see if it works. I don't care what the actual number is.
But then he converts it to hex.
I don't even care, but don't even bother converting it to hex. We'll figure out how to do the calculation correctly. But as long as the number matches, it should pass that test.
Let's try it. So we're not using the Web3 library. We're using Ethers, which is a similar library.
Wait, I don't understand. You're just looking for this? Where's the fucking chat? And in there it has this.
Yeah, that's what I was just on here. It's,
Can we just do it as from a decimal string and say, sure, do it that way? Big number 42 sounds good to me.
Well, let's see if set big number using okay. But that's what we just did, isn't it? So let me see if I get amount. Oh, let's just try to pass amount here. Maybe I thought that's what we were doing before, but let's try this again.
But you didn't define the amount.
That worked.
Cool.
And we have insufficient funds, which is right. You give permission to be granting permission. So we did define the amount here. I almost want to go back in this video and see what I was doing differently here, because I thought I was using this, but I guess maybe I just can't do 0.05. Is that just like illegal? It has to be an integer? No.
No, I think it was the shortcut that we weren't using correctly.
Okay. Cool.
Right. You were using that shortcut. You went immediately to calling that shortcut. I don't think we called the shortcut correctly.
Yeah. Yeah, we put this in the actual call here. So we did this.
Mm-hmm.
Let's see if this fails. Yeah, it shouldn't. All right.
No, it wasn't that. It was the other shortcut that you tried from that page, the tips and tricks. We'll look at it later. Yeah. So it's working. Now all we have to do is get the right calculation.
So we have the right calculation, and now we have to see if it actually is working by calling into the contract. So what I'll do here is I'm gonna move this machine over, and I'll get this. I have the wallet on this machine here.
How many machines you got at your desk?
Yeah, I got 3 of them right now.
I have 2, but one's not actually hooked up to anything.
All right, so I should be able to access this over my network. I don't know what my IP is. Not 21. What was that run on 3,000? Yeah. All right, so I'll share this screen in a second. Let me just go ahead and get this ready. Okay, so this now, I'm going to share this screen.
This was the new wallet we created to start doing all this shit, right?
Yeah. So now this wallet, I'm going to connect this wallet to our test site here. And this does have some Matic in it. And this is the wallet we use to create that test token. So we have a huge balance of that test token in our wallet. And let me get onto Mumbai. So on Mumbai. And now if I go ahead and approve, boom, give permission to access your TST. Excellent.
Very
Confirm.
cool.
Now this should send out a transaction, and it worked. So now we can actually look at this on the boom, baby.
Very cool.
It's called into the test token. We have an approve. Ha! Nice.
Okay, so now we have approved that token. Now we still have to go back and change the mint button to call for that token.
Yeah. We might actually, it's 10 o'clock. We're making good time.
Let's keep rocking and rolling.
All right, so now I'm going to stop presenting on this screen, and we're going to go back to this screen. Why is it small now? I want to make it bigger. Let's go back here. I'm going to stop. Resume presenting. There we go. Okay, so now there's a couple things we need to do. We need to go back to the back end, and we need to change our token contract.
I'm with the approve button now. We have to go back to the mint button.
Exactly. But before we go to the mint button, we have to deploy our contract with the test token as the kind of currency that we're using for paying.
Got it. And we can't use the one that we already did?
No, we can. We will. We will. Yeah.
Oh, yeah. Go to the contract to say, expect this instead of base currency.
Exactly. Yeah. We did some of that work already. So all we have to do is really take this contract address now and go back to the Nifty Artist. And here we went and we have this, we're calling it wrapped ETH. I'm just going to go ahead and plug this in here. I'll make a note, just test token. And now that might actually be all we need to do. So now in our mint, we're going ahead and requiring that we can transfer from the price of what we put, which actually we need to do, that approve button needs to get updated because you can mint multiples. We only approved for 0.05.
0.05. So we do have to create some type of range.
We have to just calculate the total price before we call that approve.
Can it prove up to that certain amount? I'm confused because how do you choose if you want to prove only 1 or 2 or 3 or 4 or 5?
Well, we have a drop down, right? So like,
yeah,
we have to, this drop down needs
we have to loop the code 5 times. If 1, if 2, if 3, if 4, if 5.
No, we just have to do the math. So like if I put 3 here, this is going to go away if we haven't approved anything yet. It's just going to be this approve. but you're going to have to select your quantity. So you're going to say 3 and then approve.
Yeah.
And then it'll do the total calculation. It'll approve 3 times 0.05.
Oh, okay. Got it. Because of the way you coded the drop down.
Right. Yeah. And maybe to make that clearer for the user, is maybe we have the amount in this button. So it'd be like approve 0.05 ETH or approve 0.1 ETH if you have 2.
Yeah,
right?
Absolutely. I like that.
Cool. All right. So now I think this should work. It's obviously only gonna work because what we just said, only with 1 token mint, but
let's do it with 1 token, man.
yeah. So now we have everything we need to be able to deploy this. We have our deploy scripts already set up. Our token, deploy upgradable token. Let me just make sure that, yeah, none of this is going to change. So let's go back to our back end. And we're going to go into our Nifty Artist project. And we're going to go ahead and run deploy upgradable token to Mumbai. This should do the same thing we were doing with our token deployment. It's going to return an address.
Cool.
Beautiful.
Man, it's so nice when you expect it to work and it does.
Right?
Like we did exactly that last time and we were very happy about it. So now we assumed it was going to work now.
All right, so now we have this address. Now we have to go back to the front end with this address and mint button. It's going to be the same ABI we're calling into. Nothing's changed. Oh no, something is changing there. Is it? Is it? Let's go back to our mint function. Do we change the? Because the mint function has a address, quantity, and amount. Address, quantity. Yeah, the ABI did change because we do need to pass in the amount too, because it's not a payable function anymore. So this is interesting. Let's see how this works. So we do have to grab from our ABI an updated.
We have to update the. Wait, we have to grab something from our ABI?
Yeah, we need this updated ABI for the mint function. So I'm going to grab this because now it takes an address and a quantity and an amount as opposed to just an address and a.
Got it.
Yeah, so let's see. Okay. Yeah, definitely something I gotta get better at is working with these large unsigned integers, especially in JavaScript, because it's too big for the size of an integer in JavaScript. So we have these libraries like the big number library that allows us to convert back and forth.
Well, that's exactly my point. I don't understand how you can't just write your own custom library so that you can put in whatever number you are most comfortable with.
Well, that's what Ethers does. I just got to get more familiar with it. Like the Ethers big number library, big number JS, I think is the library they use inside of Ethers.
Got it. So if you know the pattern for their big number call, it'll be just familiar of, okay, well, it's just that times 36.
Yeah, exactly. Yeah. So now instead of when we call this mint, we have to update this. I blew out that on my clipboard, so let's go ahead and grab that again. So the contract address, I'll just keep that in there just to.
Stupid question, though. I'm going to stick with it for that calling in and getting better at it. If you know it's that number times 36, can't you just update the big number library, call, so that you can enter it as whatever number your base number that you're familiar with? So if it's if we're doing it in a denomination of ETH, right? You can preemptively just say, here's the number, I'm going to do it in ETH. You know, I want to do it in 0.2 ETH, 0.3 ETH, 0.4 ETH, 0.5 ETH, etc. You know what I mean?
I think so. I think the issue that we have here with the front end with this type of development is it's ETH and a lot of different numeric values are expressed in unsigned integers that are 256 bits.
Yeah.
Big. They're big, right? They're like the amount the highest value can be huge. And a lot of inputs are like that. Like not just the value here, but like the quantity is actually in a unsigned integer of 256. So we constantly need to change it to a string or some other format, like the hex format we saw in that other one.
Yes. Yeah.
I think what you're saying makes sense. I think that's where that library comes into play. It does all that. It's a Swiss Army knife of converting into different formats.
Yeah, and then what you're saying is when you get more familiar, is we'll just we can take more and more shortcuts.
Yeah. It's just, I mean, it's. I think it's pretty self-explanatory. It's just understanding the APIs that are exposed to it and where those APIs live. Like with ethers, it lives in ethers.utils, right? And then under the utils there's parse ether, and you can pass in a string, and that'll return a big int string.
And this is why everyone hates Solidity.
Well, not more like JavaScript, really. Solidity does this natively.
Okay.
Yeah, Solidity it's a native. I think a lot of folks I think Python actually supports these 256 size numbers better than JavaScript. JavaScript is a little hinky on that front. But we don't have to worry, because I think we have this value here. We should be able to just literally do this and not pass it in as part of the transaction, because it's not the native token anymore. So we're going to use the same parse ether function. We're going to pass in the price, which we calculated already, and it's complaining about something. What did I do? I parse ether.
Did you set the? You have to tell it how much though.
Yeah, no, that's what I'm doing right now. I just had there was a million fucking parentheses there, so I'm still missing a fucking parenthesis. Where is the? No, I just have to add another one. All right. Okay. Cool. So I'm going to test this on this screen real quick to see if I can even hit this button. Aha. So I hit the button, and it came back with an error, sale not started. So we deployed that contract, but we need to actually start the sale.
Can we do that without having the access to Polygon scan?
Yes, because I think I wrote a script to do that. So we can actually just use the script. And I think there is or did I? Check rolls, add roll, transfer token. All right, so this set token interface. I'm going to go ahead and just grab this line. I'm going to piggyback on this script. I probably should just create a new one, but I'll just do this. All right, so this is going there. We're not going to set the base URI. Oh, we actually have this in here. So there we go. Start sale. It's going to call in there. It's going to give us. It's going to open up the sale. So This is in the set token URI script. So npx hard hat run. And this is set token URI. And we're not actually setting the token URI, right? I took that out. Oh, I am. I don't want to do that. Complete.
That's
so now,
cool.
if we look at the actual contract, which we could do here, we should see a start sale call. Nice.
That's cool.
All right, so now if I hit this button, and I'll share this screen if this works. Now I'm on the other screen here.
You go mint an NFT.
Trying to mint an NFT.
And what's cool is it still calls the same decentralized IPFS CID.
Exactly, yeah.
Right? Like it is an NFT on Mumbai already.
Yeah. Interesting. So it reverted because the transfer amount exceeds the allowance. So why is that? I thought that we said approve for 0.05. So this is where I think some of this math is hinky. It's not. But that's good though. That's an indicator that it's trying to call into the ERC20.
Yeah.
And it's saying, hey, no, you're not approved to spend that much. So why don't we do this just to isolate this a little bit?
Yeah, I'd call this pretty successful so far.
Yeah, I think we're right there.
We always get stuck at math.
Yeah. It's annoying. But let's see, if we go back to the front end here, if we change the approve button, and let's just get stupid. Let's set it to like something larger, like 10.
Mm-hmm.
And I should be able to call this approve again, right?
So again, you're approved up to a certain amount?
Yes.
Okay.
Yeah. I'm going to confirm that. That should run this transaction. Unless this amount still isn't being passed properly. Like if this one still doesn't work, then we're not passing this in properly. Okay, so now I just approved up to 10 of this test token. Now I'm going to hit this mint NFT, and I got the same error. Transfer amount exceeds. So we're doing something wrong with this approve button. So let's see. Maybe we can find. There's got to be a bunch of examples of this. So.
Approve. Oh, that's cool. I check out this page that I was looking for the code, and I found something cooler. Revoke.cash is where you can review all of your ERC20 approvals and revoke them.
Oh, nice. Yeah, we've talked about that before. Like, really,
It's a security vulnerability.
yeah, and we're all over.
It's a really dangerous one because, like, no matter what, even if you protect your private key, then a hacker doesn't need your private key because you're basically already gave them permission to do this stuff.
Yeah. Yeah, so if any contract that you've approved for gets compromised, they could just take everything. We'll take all that token. We're doing something like trivially wrong here. It's always what happens, right? You get caught on something stupid. It's like the damn screw won't come out. Come on, I know what I gotta do. I gotta take the screw out of the damn thing.
Take a look at, I guess, this.
I gotta learn the big numbers library here. This is many operations operate on numbers which are outside the range of safe values to use in JavaScript. A big number is an object which safely allows mathematical operations on numbers of any magnitude. In most operations which need to return the value. It's funny, this big number class, this is one of the first things we did in high school computer science. We actually wrote this class in C++. And it was like completely like, why do we have to do this again? Like, we're just, what?
Just to show you how annoying computers are, because they only recognize ones and zeros.
Yeah. And it's so ironic that I'm actually like looking at this again. Like, what? It's amazing.
Annoying. But what's funny is that big number-ish. That just makes my day.
Yeah, like, what is that?
Big number wasn't nondescript enough.
Yeah. Many functions and methods in this library take in values which cannot be non-ambiguously and safely converted to a big number. These values can be specified as string, bytes, like big number, creating instances. See, here it's just going straight big number, but this has got to be in. Is it ethers.bignumber? Is that all it is? Is it just ethers?
Well, that's what I was trying to say. Just put it as ethers.bignumber5 and call it a day and see if it allows it.
I'm saying like that?
Yeah. Well,
okay.
The example went with 42, but let's stick with 5.
Yeah, let's try it. So let's see if we go.
And you approved up to 10, so cool.
Okay, no, this is creating a new, so it's got to be that. So we're going to create a new instance of this. Cannot call constructor directly. Use big number from. Okay, so this is okay, so we got to do that. Okay. Okay, that let me pass it in. I'm on the other screen now. Let's see. I'm going to confirm this. We're approving again. All right, it approved it. And now let's go mint. Transfer amount exceeds allowance.
Whammy.
What the hell, man? What are we doing wrong? We are doing something wrong.
Transfer amount exceeds. Hey, check this out. I'm pasting it on Google.
Maybe we're looking in the wrong spot. Maybe our mint function is not passing in the right value, and it's passing in some freaking huge value. We're saying price to string parse ether. What if we
just big number 5 that?
Yeah, just big number. Yeah. Just say let the total price equals ethers dot big number dot
from
price. And then give it a total price here. Let's see if that does it. Nope. What is this? Underflow. Big operation from. Oh, I think maybe value 0.01. It may actually have to be
an integer.
No, does it have to be a whole number? No, that doesn't make any sense.
Well, no.
Let me try. If I put 1 in here. No. Getting the same error.
So wait, go check out the. This is a truffle contract. Version needs to be approved and transfer. Look at the website I just sent you on the chat.
Oh, cool. Yeah, I was actually just looking at the same page.
Okay.
Nice.
It's the transfer from, they're saying.
So I think the issue here, what is the issue he's having here? I'm trying to use the approve and then transfer from methods from the Open Zeppelin library to transfer ERC20 from an account to another through my contract approve. Seems fine. Seems fine. Allowance returns the expected value. But after that, transfer from with the same address reverts with transfer amount exceed allowance.
Yes. And then he's saying you're calling it from the wrong owner.
Oh, so maybe we have. Wait a second. What are we passing? Oh, this is good. This is a good one because what do we? Let me revert all this shit because this is probably right. When we call approve, we're approving ourselves to spend it.
Exactly.
We have to approve the contract that was going to do this. So we need.
That's cool.
Yeah. So it's not the. So the test token address is this. This is what we need to pass into the approve, not ourselves. We're already approved to transfer the token because we
our wallet.
Our wallet. So we're gonna put. No, I put that in a variable. It's like test token address. There we go. So let's see if that works. So now we do have to call approve again because I'm feeling pretty good about this one. So I'm gonna share the screen and we'll watch this one fail together. Okay. So we're going to go ahead and approve. Okay, give your grant permission allowing the following contract, which that's 1770 should be what we're ending. Okay, good. So that's good. Confirm. Now this should, excellent. Now,
all right. Which is that?
Damn it.
Same transfer amount, right?
Yeah, same transfer amount.
Okay.
ERC 20 transfer amount exceeds the allowance. Oh wait, did I change the mint button though? No, 0.05 times quantity. Let's try this. Oh. Damn it, did I just... Just make sure I have the right contract address in there.
We're asking our mint function to transfer based on the allowance that they've given. So it's the mint function's contract. Yeah.
Yeah, hold on. I think I got it. I think maybe I had the wrong contract address in the mint button.
Yeah.
So I'm not getting what I want, but let's see.
I don't know why you have to approve each time. That you shouldn't have to.
No, we shouldn't have to approve now. I think we're past the approval piece. I think now the mint button needs to be invalid big number value. Okay, so now let's try this. Let's try this with this big number. So now we're going to take this out again, which I guess I just... Let's try that.
Same error.
Damn it. Same error now. I just control Z stuff that RPC error.
Whoa. Hold on. Do you have this code in there? Where it's actually trying to do the transfer? Show me that again.
On the back end or the front end?
The mint, I guess, the back end.
So transfer from the sender to this address for the total price. This looks right. Oh, wait, I'm not sharing that screen, am I?
Where are we doing the transfer? Okay, transfer. But where are we transferring the ERC? Yeah.
This line right here does that. This is the call.
Oh, transfer from. But how come they're not doing a transfer from the code I pasted you? They're not doing a transfer from. They're doing a transfer.
Oh, let's see.
Check in the Google chat that I'm sending. I clicked the link where he says, I think the issue here is that transfer from expects to be the beneficiary, and it brings up all of his code of where he's referring to.
Yeah, so I think that's what we're doing, right? The transfer from the beneficiary here is the contract address, which we just approved.
But they're not doing, but what I'm saying is in the code that I'm looking at that he was referring to, he's not doing a transfer from, he's doing a transfer.
Where do you
not
see
up
that?
there. Here, let me share my screen for a sec.
Cool.
That screen. All right. So I went to here. He linked us to line 154. And he's doing a transfer, not a transfer from.
But that's inside of the transfer from function. So that's internal to the transfer from function. So you're inside the function that we're calling right now.
Okay.
So like we're calling this function. That's exactly what we're calling. So we're calling transfer from. We're passing in those 3 parameters, and the first thing transfer from does is actually perform a transfer.
Okay.
Yeah, I think Paul. I think that call is correct. This is the same call that other project we were looking at is doing, too.
In this case, the token contract itself.
Is there a way to like determine on the ERC20 how much you're approved for? Yeah, I don't. Let me try on this screen again here.
So let me just, I don't know how much further we're going to get, but let me at least try and sum up what we've done so far. So we can deploy our NFT contract to Polygon. We can approve an external ERC20 as payment. We can call for that ERC20 as payment. However, we can't get the math and the call correct.
Yeah, so let's check this out. Exactly. So if we go here, you can look at this, the details of this transaction. You can see the approve amount in the permission request, and we're granting this contract, granted to this contract, which is correct. Let's go ahead and look at, what was that other project that we were modeling? I keep forgetting the name of it, with those NFTs that were on Polygon.
Head 5.
Head 5. So if I go here, I'll connect our wallet here. Damn it. All right, so we'll do that. And, oh no, I'm in the wrong browser. That's fine. I'm like, wait a second, I'm already. Okay, I'm going to connect this. Okay. Oh, we got to switch to Polygon. Connect. Okay, so now, so they do the drop down too. So you're going to do the drop down. I'm going to approve. Now let's see. We go to full transaction details. Yeah, we're definitely doing this wrong because look at this. This is well, maybe because it's wrapped ETH, it's giving us this nice clean look. But if we do it on our site, we're getting, oh. That was not like that before. It just has 5, which is correct. That's exactly what we wanted to do.
Yeah, but that's not our problem. It's the mint.
Yeah, but we're not sure though. Like, so I think. Oh, I'm on the live. I'm on live. That's why. So now it's saying 5. If I go to the test net. I'm getting this, which I think is right though. But this could be a really, 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 really small number. I don't think it is. Let me. God damn it.
Isn't that a really big number?
Yeah, I think it's a really big number.
Can you use number 42 then? That's what Etherscan. That's what the Ethers library used as a sample.
Okay. So now if we use 42, I'm going to reject this. Go to details. It's doing the right thing because now, 42.
I hate math.
I hate this type of math. This is annoying. It's just.
Yeah, it's because it's like encrypted math.
Yeah.
And we can't look at anyone else's code for this because it's on their front end.
Yeah, it's all like, it's probably all packaged up in a. All right, so now this transaction went through. I think we're going to get the same error. God damn it.
All right. Let's, unless you want to keep whacking at it, I think we can kind of take a break. I think we're really close. We just need to figure out what that number, how to call numbers.
Yeah, how to pass in the number to either the approve or the mint. One of those is messing up.
So I think that's something that we can research and solve through the day tomorrow.
Yeah, let me try one more thing before we call it quits.
Oh, that's some hair. My hair was sticking up.
$22. It's a big number. We're passing that. Do we have to do 2 string? Okay. So
I'm going to pee and fill my water. And when I get back, either you're going to say we were successful or we're going to talk about something else.
cool. All right, so I'm trying to use the parse ether function for the approve, and it looks like it nicely formatted this 50 test, which is what we expect. Confirm that. That confirmed. No.
No?
I think we saw the wrong contract address in here. So this is contract. Oh, am I just being an idiot? So this.
Wrong contract address, as in you're not approving the token.
Yeah, what is the test token address that we have here? We have start sale. It ends in C66. C66 here. Approve button should be going to C66. I think I'm just going to the wrong freaking contract. Hold on. What screen am I sharing here? All right. So let's see. We're going to approve here. Test token address ends in 1770. Yeah, wow. Just like all these damn contract addresses flying around. So, yeah, I'm messing this up. Hold on. So now, okay. So we're gonna use this. Let me share. What screen am I sharing here? Oh, I still got.
Yeah, I'm seeing you code.
All right. So this contract address in this approve button, this needs to be here. This contract address is what we're going to need to use in the, not the test token. So we went from approving our own account to approving the token address to spend itself, which is wrong. And now we need to actually approve the NFT contract that we've been trying to do for almost an hour now. So let's see if this one now works.
Hard on yourself. We made great progress about 20 minutes ago.
Yeah, it's so we're gonna approve. Okay, so let me share this screen because all right, now I'm feeling pretty good about this. Maybe I shouldn't be optimistic.
Despite the fact that it's still a really big number, but we went with number 42 to sample this time.
Yeah. So I'm gonna approve. Now this should be approving.
Screen. Cool.
This should be approving access
CC6.
your funds CC6, which is the contract address, the NFT contract address, and it should be approving. Actually, I bumped it to 50 TSD, okay, which is right. I'm gonna confirm that. Okay, that approved. Awesome. Now let's try to do a mint. Oh yeah, baby! Yes. So let's see if this works. So calling mint. Interesting piece about this is now the mint doesn't have like a value shown to the user. Did you have that same experience with the Head 5 contract?
What do you mean it doesn't show a value?
So like, I don't see how many wrapped ETH I'm spending right now on this. So I'm gonna confirm this. That's gonna send out a transaction, which succeeded. Nice.
Quickly. That's cool.
Now if we go out here, it did mint.
0.05 test.
And yep, so it did the right thing. It transferred 0.05 test to this contract. Now, if we look at this contract, we should see 0.05 test in the balance.
Wow.
We did it.
Cool. So when we next do this, we are deploying it on Polygon, right?
I think so. I mean, we'll probably write some tests here. I got to clean up this.
That's why I said when we next do this. We're not doing it today.
Yeah, we're not going to deploy this.
When we next do this, we are ready to deploy. Put it on our multi-sig, which we still got to screw around with. I don't want to do that tonight yet, but we know it's. I think the thing I want to test on the multi-sig is not using their front end. Right, that's where I need you. Right, let's use command line calls for the Gnosis safe. And maybe even create our own little front end tool if we need to, and feel really comfortable about that multi-sig.
Yeah, no, for sure. That's definitely I think tonight definitely helped with some of this this parse. It's actually, it seems like it's simpler than I'm thinking of. I think I may be overcomplicating this a bit, because I think a big part of a lot of this type of development is getting comfortable, especially from a front end perspective, on working with these numbers, because you can really screw this up royally if you're not working. Yep. Right? It's the classic what's that movie, Office Space? I put the decimal in the wrong spot. This like takes it to the next level, right?
Yeah. Yeah, but I don't care. It functioned, and we can do math later.
Yeah, I mean, right now we're approved up to 50. I think we are doing the math here. So if I go back here and say I want to approve, I want to buy 3 of them, it'll work. The only thing I don't like is it doesn't show the user how much they're actually spending of that.
Yeah, token. But I think that's a symptom of the fact that you're a random fucking contract.
Yeah, maybe wrapped ETH MetaMask will behave a little differently.
MetaMask will recognize wrapped ETH, where it won't recognize whatever you got.
So now that has 2 mints, and our balance should be is that right? Yeah, 0.05 was the price, right?
Cool. So what I would suggest when we do this mint, when we do the front end, rather than we'll just approve up to the 5, right? Like since you can only mint 5 as a max, we'll approve up to 5 and then we're done. We won't allow them to mint more, or we won't approve. We should probably look at what some of the standards are, right?
Yeah, definitely. Curious to see what others have done here, because like if somebody comes back and mints again, they're gonna have to approve again.
Yeah, exactly. And we don't want to do that.
Yeah.
It'd be nice if approve calls had a block timer on them. Approve for 1 week, approve for 5 days, approve for, like,
It's a good idea.
Right in the IP.
Yeah, approve for, because you could do it just based on the number of blocks. Approve for the next 300 blocks, which is a month or whatever the hell it is.
Yeah. But then, does it need to have a closed loop, or it automatically executes where the next time it gets called, it'll say, nope, block number is higher than X, therefore fail transaction.
Yeah, I mean, my initial thought is like you can extend the approve function to include like we're right now we're passing in the contract address that we want to approve and the amount, and maybe we just pass in another value like block count or something like that. And then in the contract itself, in the approve method of the contract, it could do a test and say, hey, if the block number is greater than the block that you passed in or approved.
Yeah, and then taking the customer experience and from the next time, like we should have a front end that does a check of whether or not they're already, they're approved or not, which we should be able to do, right? I think.
Yeah. I think so. Yeah.
And then like, hey, you need to approve again. It already expired.
Yeah. Interesting.
Well, that's a whole other story and day. Okay. Well, cool. I think we're good to go. We have success. You're gonna write a bunch of test scripts, but we can deploy Jordan's contract. We just have to go and get the wrapped ETH contract addresses and just do it.
Yep, exactly. I mean, I think we're ready.
This was our test to see that we can do it for an ERC20. Now all we have to do is do the correct math against wrapped ETH.
Yep.
Cool.
Polygon
wrapped ETH, which is different than wrapped ETH, which is different than ETH. It's fucking crazy. Yeah. So let's stop the record. I think this was a good success. We'll take a look through and see how quickly we can go from cool, we recorded it, to cool, it's sanitized, and let's post it.
Yeah. Excellent. All right, cool. I'm gonna go ahead and stop. Where is the stop button? Here it is.